Okay, in this video we're going to look at the derivative of general exponential functions. Again, this is just a tutorial on how to apply the definition, not to replace the classroom experience where we would discover, we would have diagrams, we would talk to each other about it. But again, this is a nice tutorial on how to use that definition. So we looked at the derivative of exponential functions when you have base e, that special irrational number. So now we're going to look at when it's not base e. So I always like to have an example down. So I'm going to look at this example here. Y equals 2 and raised to the exponent 3x. So one thing I want you to notice here, notice over here, you've got a couple of parts. You've got base b, and then in the exponent you've got g with respect to x. So if we're looking at this example here, the 2 would be the b we're talking about. And I'm going to get my highlighter out. The 3x would be the g with respect to x. So I'm going to start with that g with respect to x. It's going to be 3x. And I'm going to need the derivative of that, g prime at x. Now going to the definition. The definition says you rewrite y prime as b with g to the x. So basically what you're doing there is you're just rewriting the original function you're given. Now this is all multiplying, so I like to use brackets. Multiply the natural logarithm of that base b, so in our case here, the natural logarithm of 2. And multiply by g prime at x, which in this case is 3. And that is it right there. Now, it might not look great. You might want to multiply and factor, but you can't. Like one thing you're not allowed to do, like this part right here, you can't multiply that 2 and 3 and say natural logarithm of 6. You can't do that because then you're disturbing the natural logarithm of 2. So we don't want to do that. And then likewise over here, like you might be tempted to multiply that base 2 and 3 and say something like 6 to the 3x. Again, you can't do that because then you're going to disturb that base 2 and the exponential function 3x. So again, just going to leave it just like that. And if you want, you can rearrange the parts and just say, like, if you want, you can do this. Go back to this. Like, you just rearrange it and say 3 times 2 to the 3x times natural logarithm of 2, but not necessary. Okay, look at one more example. So how about this one here? How about y equals base 5 to the 3x minus 2. Let's identify g with respect to x. And we're going to need that derivative. And using the definition, so you're basically rewriting the original function times the natural logarithm of that base times that g prime, which is 3. Again, leaving it like that is fine, or rearranging the parts. We're not multiplying natural logarithm of 5 and 3 and saying natural logarithm of 15 or something like that. That would be incorrect. And that is how you apply the definition.